This is just a small demonstration of applying practical AI tools to a real-world problem scenario. In this case, we're using maps, satellite imagery, and deep learning. For this example, the issue is trying to identify trees nearby a working rail track. These would potentially pose an impact risk to the vehicles and possibly a fire danger. We'd like to locate the trees near the track and produce a usable display report of potential risk locations. So to demonstrate a simple app for doing that, we'd like to be able to navigate to a bit of UK that might have some nearby trees on it. Navigating on the left-hand side here and just displaying some satellite imagery from Google Maps on the middle panel. And so yeah, let's get that nicely centered. We'd like to be able to just get the rail track and a few meters each side as a mask. From that mask, we'd like to be able to apply machine learning models to determine what trees can be found in there. So there's two models being used to do that. I'll go through that in a moment. So let's show nearby trees there. And it's not done a perfect job, but it has given you an indication of the trees that are nearby the track. So once we have that available to us, that sort of information can then be exported as an image or then download more useful in formats like GPX or KML. As I mentioned before, this is just a simple web application. On the left-hand side, we're using OpenStreetMap to provide a navigation widget. Next to that, there's a Google Maps widget giving us some satellite imagery. And we're using a layer on OpenStreetMap to provide the rail network of the UK. That's provided by Thunderforest. That provides us with some masking capability so we can identify where the track is in the satellite image. Once that track is masked off and identified there, that mask is then used in a deep learning model called Deep Forest to identify the trees that are near to the track. The tree location bounding boxes are then passed on to a segmentation model called Segment Anything, produced by Facebook, now Meta. That gives us the rough shapes of each of the individual trees there and produces this final image we see at the moment. The final image can be downloaded as JPEG or PNG, or their GPS locations dumped to a report format. All the tools used in this demonstration are, at the very least, available for personal use without charge, and most are open source. There's a list of the main technical components in the posting below. This application works well enough as a simple demonstration for capability, but really it could be improved in a lot of ways. The rail masking, for example, is done off a OpenStreetMaps layer. Ideally, you'd be getting this information from somewhere like Network Rail's open data feeds. The tree detection also leaves a lot to be desired. You can see it's picked up some of the trees close to the track here, but missed others that it really should have shown, and also you can see some false positives here as well next to the motorway. You like to really be tuning the tree detection on the imagery you've got available, ideally fine-tuning your own segmentation model on this satellite imagery for the country involved, in this case the UK. Even better, you'd be using more types of imagery. I've just used the Google Maps widget here for satellite imagery. Ideally you'd have LiDAR and multispectral imagery as well to combine. I've seen some very good results when people have done this. With this information available to you, you've also got the possibility of trying to identify the species of trees by the side of the track. I've seen some good results for this as well, but I've not covered that in this work. You'd also like to have the dates the satellite images are taken there, so you know how old the information is and whether to expect a significant growth on the trees is worthwhile doing inspection. And you could also have different report types from this and go a lot further than just looking at one image at a time there. Possibly have an automated system that does this over whole sections of track in one go. Hopefully you've enjoyed watching this video, and it's given some indication of the capability of AI using freely available tools, techniques and data sources applied to real-world problem scenario. In this case, applying deep learning tools with satellite imagery to identify trees near working rail track. Thank you.